Assalamu alaikum students, this is Fazal Wahab. Today's video class is the continuation of the topic differentiability. In today's class we will find out the relative maximum and minimum values of the functions. In today's class we will just only target the questions which are important, very important regarding the examination point of view. So we will solve the exercise 5.3 regarding the Karachi textbook board syntax book. So this is the exercise 5.3 and the questions which we are solving is exercise 5.3. The question number is 2. Question number 2 is f of x is equal to x cube minus 9x square plus 15x plus 3. This is the question and we have to find out the relative maximum and minimum values of the function of this function. F of x is equal to x cube minus 9x square plus 15x plus 3. First of all, what is a maximum and minimum values? What is a maximum point? What is a minimum point? For example, we have this curve. Let's say we draw a graph for this curve. Let's say this is a curve with us. This is a curve, and let's say here is 1 and 2 and 3. Similarly, 1, 2 and 3. What is this? Is a cup up shape curve. This is a cup up shape curve means like this one. This is a cup. This is like a cup. And it is cup up shape. Okay, so this is a cup up shape curve. It has always a minimum point. The cup up shape curve has always a minimum point. Why it's a minimum point? Because the value of f of x is the value of y axis. Okay, here is the value of y axis. Let's say it's 2. So 2 is the minimum point on the y coordinate because the curve are not coming down. That's why it comes down only to the value 2 and then it goes up. So it will never comes down below the value of 2 on y-axis. So that's why it has a minimum point. Minimum point f of x will have a minimum point on this curve and that will be equal to 2. So that is the minimum point. And if I draw another curve, let's say this one is another curve. Let's say this one is the another curve. This is called cup down shape. This was cup up shape and this one is cup down shape. It will always have a maximum value. Maximum value means this is the maximum value. Let's say it is 10. So suppose this y value has 10. So it's a maximum value because the curve is returning from the value of 10. It has a maximum value and then all the remaining values are less than 10. This is 9, this is 8, this is 7 and so on. This is minus 1. So all the remaining values of y for this curve is less than 10. The maximum value of this curve at y is equal to 10. So this is the maximum point. This is called maximum point and this one is called the minimum point. So these are the maximum and minimum points and we have to find out here in this case we have to find out whether a curve has a maximum or a minimum point. One another thing, and what are these points? Okay, so we have to find out the value of these points and whether a curve has a maximum or a minimum points. Also we have to find out this one. So how to find out a curve, the maximum or minimum point of a curve? We need to find out another thing. We need to find out the derivative of this one. When we will find out the derivative of this one, we will get the slope of this one. Derivative of this function means the slope of this function. We will find slope to this curve or this one, this function. We will find out the slope to this one. Now, at maximum or minimum point, these are also called the stationary point. This one is the stationary point. This one is also the stationary point, where the tangent to this point, tangent to this point and tangent to this point will always be parallel to the x-axis. For example, this is tangent to this point and this is tangent to this point. Okay, so this line is also parallel to x-axis. This line is also parallel to x-axis. So tangent to the maximum or minimum point of any curve will always be parallel to x-axis and will have a gradient equal to 0, because x-axis has gradient equal to 0. Therefore, the tangent to the stationary point will have a gradient equal to 0. That's why we need to find out the gradient of this function, and then we will make that gradient equal to 0. We will get the value of x and y. Another thing which I wanted to explain, for example, I have this cubical functions, x cube minus sin x square plus 15x plus 3. So the cubical function will have a curve like this one. This one like this one curve. That will have 2 points. This one maximum point, one minimum point. So we will have to find out this one. Let's solve this question. The question is, differentiate y or f of x, same thing, with respect to x. So f derivative of x means different d over dx of x or derivative. So that is equal to 3 by applying the power rule here. It is 3x and 3 minus 1. Okay, let's do one more step. D over dx of this whole x cube minus 9x square plus 15x plus 3. We need to find out the derivative of this whole function. So d over dx of x cube will become 3x 3 minus 1. Power rule means d over dx of x to the power n. That will become n, the power will become the exponent, will become the coefficient of this one, and x power n minus 1. This is the power rule. We have already explained this one. So 3x 3 minus 1 minus 9. Coefficient, we will carry the coefficient because 9 is the coefficient of x square and there is no derivative of the coefficient of any of x square or x of the variable. Therefore 9 will be carry on. So 9, and we will apply the power rule on x square. So 2x 2 minus 1 plus 15 is the coefficient, that will be carry on, and x 1 minus 1 plus 0. Now here is 3x square minus 9 to the 18x plus 15, x power is 0, therefore it will become 1 and we will get 15 only. So this is the f derivative of x. Okay. Now we know that dy over dx or f derivative of x is equal to 0 at stationary points. Stationary points. Therefore, 3x square minus 18x plus 15 will have the value equal to 0. Now we are going to find out the value of x at the stationary points, at the maximum or minimum points. Now we will factorize this one. So we will get 3 is common here. So you got x square minus 3 6 is 18, 6x plus 3 5 is 15. You got 3 is common. equal to 0. Now this 3 will be shifted here and this will become equal to 0. Therefore, x square minus 6x plus 5 equal to 0. Now 5x square, we will do the breaking the middle term. We will solve this one, factorize it by breaking the middle term. Okay, so x square, okay, 5 minus 5x and minus x. When we will add both of them, we will get minus 6x, and when we will multiply this one, we will get the product of the first and the last one. Okay, so 5x square, we need two terms of minus 6x. When we will add both of them, we will get the minus 6x, and we will multiply both of them, we will get the product of the first and the last one, which is 5x square. So plus 5. These are two things, minus 5x and minus x. When we will add up both of them, we will get minus 6x, and we will multiply both of them, minus minus plus, 5 1 is 5, x into x is x square. So equal to 0. Now x is common here. So x into x minus 5. Minus 1 is common here. So x minus 5. We are just factorizing it. X minus 1 into x minus 5. You got 0 here. X minus 1 is equal to 0. X is equal to 1. And x minus 5 is equal to 0. X is equal to 5. Okay, we got two stationary points. One will be maximum and the other one will be a minimum point. And the two stationary point whose x coordinate is 1, for the second stationary point, the x coordinate is 5. Now, which one is maximum point and which one is minimum point, we need to find out that one by taking second derivative of this function. One derivative we have already taken it here. We have solved the first derivative here. Now again, take second derivative. Second derivative of the function means we will take another derivative. We will use this symbol for the second derivative is equal to d over dx of the first derivative, which is 3x square minus 18x plus 15. Power rule, we will use the power rule. 3 into 2x minus 18, 3 to the 6, x minus 18. Okay. Now this is the second derivative of this function. First derivative is this one, and we got second derivative of this function is this one. Why we find out the second derivative of the function? This is for the test to find whether a point is maximum or minimum at x is equal to 1 and maximum or minimum at x is equal to 5. How can we do that? By putting the value of x is equal to f double derivative, okay, to find the maximum or minimum value of the function, to find the maximum or minimum value of the function, put x is equal to 1 and x is equal to 5 in the second derivative. Second derivative. So, if second derivative of x value, put the value of x is equal to 1, you got 6 into 1 minus 18. 6 ones are 6 minus 18, you got minus 12. Minus 18 minus 12. So f double derivative of x at 1 is equal to minus 12, which is less than 0. Therefore, f second derivative of x, which is minus 12, okay, therefore function f of x, which is curve, has maximum value, and we will find that value, maximum value at x is equal to 1. Now f second derivative of 5. Now we are finding this one, testing this one for x is equal to 5. So 6 into 5 square, 6 5, only 5, sorry, minus 18, and 6 5 is 30, minus 18 is equal to 18. Minus 18, sorry, minus 18. 30 minus 18 is 12, which is greater than 0. Therefore, f of x has minimum value at the point x is equal to 5. Now to find out the minimum and maximum value, for minimum value is for x is equal to 1, and the maximum value is for, the maximum value is for x is equal to 1 because it has equal value minus 12, which is less than 0, therefore it has a maximum value. Now, how to find out the maximum value? By putting the value of x is equal to 1 in this function, and we will get f of x is equal to something. That will be the maximum value, and for the minimum value we will put the value of x is equal to 5. This whole process from here to here, from here to here, this was just for testing whether this function has a maximum or minimum value. So we find that values for x is equal to 1, the function has a maximum value, and for x is equal to 5, the function has a minimum value. We just test that in the second derivative and we got minus 12. So the function has a maximum value at x is equal to 1, and for x is equal to 5, the function has a minimum value. What are these values actually? This was only for testing. Now we need to find out these values, as we don't have the space here, so I have to remove this part. Now to find out the maximum and minimum value. Okay, so first the maximum value. Okay, for maximum value, okay, write this one. For maximum value, put x is equal to 1 and f of x. So f of x is 1 is equal to 1 cube minus 9 into 1 square plus 15 into 1 plus 3. Here is 1 cube is 1, minus 1 square is 1, 9 ones are 9, plus 15 ones are 15, plus 3. So 3 plus 1, 4, 4 plus 15 is 19, 19 minus 9 is equal to 10. So the maximum value is 10 for f of x, and now the minimum value put x is equal to 5 and f of x. So f into 5 is equal to 5 cube minus 9 into 5 square plus 15 into 5. Just put the value of x is equal to 5 in this whole function. 15 into 5 plus 3. You got 125 from 5 cube, and 5 5s are 25, 25 9s are 225 minus 225 plus 15 5s are 75 plus 3. And when you will solve these values, we will get minus 225 plus 125 is minus 100. Minus 100 plus 75 is minus 25. Minus 25 plus 3 is minus 22. we got the minimum value is minus 22. So we got both the values. For maximum value is equal to 10 and the minimum value is minus 22. And this is the solution of the question.